Next, see geometry and locus of complex numbers. What is it? Geometry and locus of complex numbers. Geometry and locus of complex numbers. Geometry here mentioned is nothing but a Argand plane. Already we have studied in the 4th or 5th class. Argand plane. That Argand plane is here mentioned geometry. And locus is nothing but a point and a complex number. See example 2.18. Example 2.18. Given the complex number z equal to 3 plus 2i, represent the complex numbers z, iz and z plus iz in the Argand plane. Show that these complex numbers form the vertices of an isosceles triangle. Show that these complex numbers means z, iz, z plus iz form the vertices of an isosceles triangle. To prove that these vertices form an isosceles triangle. Am I right? See, z is a complex number given that 3 plus 2i and z, iz, z plus iz be the vertices of an isosceles triangle. Okay, to prove that these are the vertices of an isosceles triangle. Now, read it again the question carefully. Given the complex number z equal to 3 plus 2i, represent the complex numbers z, iz and z plus iz in the Argand plane. Show that these complex numbers form the vertices of an isosceles triangle. Now, given z is equal to 3 plus 2i and iz be the vertices. So, iz is equal to I into 3 plus 2i, which is equal to I into 3 plus 2 into I into I is I square, which is equal to 3i plus 2 into minus 1, that is minus 2. So, iz is equal to minus 2 plus 3i and z plus iz is equal to z is 3 plus 2i, iz is minus 2 plus 3i. 3 minus 2 is 1. 2i plus 3i is 5i. Okay. Now, let take it as A, B and C. B, Z and Z plus IZ and IZ respectively. We take Z plus IZ be the vertices of the triangle ABC. Okay, now see the Argand diagram. Z plus IZ values we found using in a Argand plane. Z values 3 plus 2i. We can write it in a ordered pair. 3, 2. 3, 2. So, x-axis 3, y-axis 2. So, 3, 2. It forms a, so let's take it as A. Vertices A. And then, second, IZ minus 2 plus 3i. So, ordered pair minus 2 plus 3. X-axis minus 2, y-axis plus 3. Okay. In a diagram, always numbers or letters denoted in anti-clockwise. So, here take it C. Take it vertices C. And then Z plus IZ values 1 plus 5i. It can be written in order pair 1, 5. So, x-axis 1 and y-axis 5. So take it the vertex as C. Take it the vertex as C. So only here take A, B, C, B, Z, Z plus I, Z and I, Z respectively. Now find the length of these vertices. AB square, which is equal to, why here we find AB square? Since the isosceles triangle proof is AB square plus BC square, which is equal to CA square. Here prove that isosceles right triangle. So AB square plus BC squared is equal to CA squared is a proof. Okay. Now consider AB square. AB square is nothing but AB the whole square. AB means Z1 minus Z2. So here vertices A is Z. B is Z plus IZ. So B minus S. So Z plus IZ minus Z the whole square. Or Z2 minus Z1. See the formula. Since length of AB is equal to modulus Z2 minus Z1. Okay. So here Z2 minus Z1. And then modulus of here Z and minus Z get cancelled. Z and minus Z get cancelled. Finally IZ the whole square. Modulus IZ the whole square, which is equal to IZ values minus 2 plus 3I the whole square. Am I right? So modulus mean taking square root. Square root of minus 2 squared is plus 4 plus 3 squared is 9 the whole square. Here square and root get cancelled. We got it 9 plus 4 is 13. So AB square, which is equal to 13. AB square is equal to 13. And BC square is equal to modulus of C is IZ. C is here IZ minus B. That is Z plus IZ. So IZ minus Z plus IZ the whole square, which is equal to modulus of IZ minus Z minus IZ the whole square, which is equal to plus IZ minus IZ get cancelled. So minus Z the whole square, which is equal to square root of minus Z square the whole square. Am I right? Or otherwise we simply write it as here modulus of minus Z values 3 plus 2I the whole square. Okay, which is equal to modulus of minus 3 minus 2I the whole square, which is equal to taking a square. Minus 3 squared is plus 9 plus minus 2 squared is plus 4 the whole square. Square and root get cancelled. Square and root get cancelled, which is equal to 9 plus 4 is 13. What is the left hand side? BC squared is equal to square root of 13. Next find AB squared found, BC squared found, then find CA square. That is CA square is equal to A minus C. Here vertices A is Z. C is IZ. So we can write it as Z minus IZ the whole square. Z minus IZ the whole square. Z is 3 plus 2I minus IZ is minus 2 plus 3I the whole square, which is equal to 3 plus 2I plus 2 minus into minus plus 2 plus into minus minus 3I the whole square. Now 3 plus 2 is 5. 2I minus 3I is minus I. So 5 minus I the whole square. 5 minus I the whole square, which is equal to square root of 5 squared is 25 plus minus 1 squared is plus 1 the whole square, which is equal to square and root get cancelled. Square root of 26. What is it? C a square, which is equal to square root of 26. Now consider the result. AB square plus BC square, which is equal to, what is AB squared value, BC squared value? AB squared 13, BC squared is also 13. Here 13 only. And then here also root 20, not root 26, only 26. AB square plus BC square, which is equal to AB square value is 13 plus BC square value is also 13, which is equal to 13 plus 13, which is equal to 26, which is equal to 26 is CA square. So what is LHS? AB square plus BC square, which is equal to CA square. So given vertices form an isosceles triangle. Therefore, triangle ABC is an isosceles triangle. ABC is an isosceles right triangle.